Let's take a look at working with position and velocity for space curves using Maple. So imagine you had this problem. Plot the space curve t sine t, comma, t cos t, comma, t over the interval t between 0 and 10, but you also want to plot the position and velocity vectors at the midpoint. So there's a couple things I'm going to do here. First thing is, since I'm going to be doing plotting, I'm going to type in that with plots command. That just gets me started. The next thing is, since I'm going to be working with this and doing lots of stuff with it, I'm going to be plotting it, evaluating it, taking derivatives, it's helpful to name these guys right here. There's actually lots of different ways to work with vector-valued functions in Maple, but I'm just going to take the easiest one, which is to treat each one of the components separately. So I'm going to write a function for the x component, which is t times the sine of t. I'll write a function for the y component, which is t times cosine of t. And I'll write a function for the z component, which is t. And remember, this is the basic syntax for a function. Name of the function, the input variable, the output value. So now I've got this right here. So to plot the space curve, that should be easy enough. I use the space curve command, and the curve I want to plot is x of t, y of t, z of t, over the interval t going from 0 to 10. And that at least will get me a start, and then I can modify as need be. So there's the curve. Let's do some basic things. I'm going to make the curve bright blue. I'll make the curve thick so that I can see it better. I will make the axes apparent, so axes equal normal. And last, I'll make sure that the axes have labels, so labels equal x, y, z. And so there's my revised graph, so I can see it a lot better. Apparently, it's a really a tornado maybe? Got a nice spiral, it's coming out, getting bigger and bigger and bigger. So the midpoint is somewhere in this halfway point right here. So we want to be able to get a position vector who would point to it and a velocity vector who would show me the tangent direction. Now to get the position vector, that's pretty easy. That's just that arrow command from one of our earlier podcasts. So we type in arrow. Now the position vector at 5 is just x of 5, y of 5, and z of 5. I don't need to actually work out those values. Maple will do it for me. And there, it gives me that arrowhead. Let's color code this red. And now I'm going to put the two pictures together. So you might remember I can either drag and drop, but with arrows, that tends to be a problem. So instead, I'm going to name these things right here. So let me just call this the tornado, colon equals tornado. Let me call this the position vector. And let me display those two things together. I'm going to display the tornado and the position vector. So there's where I am at 5 seconds, and about halfway up right there. Now I want to work out the velocity vector. So the velocity vector is going to be the arrow whose components are the derivatives. Unfortunately, you can't type something like this. This seems like the obvious first candidate would be to type x prime of 5, y prime of 5, and z prime of 5, because that's how we would do it in class. Unfortunately, you get an error message right here because Maple used the prime for text cells. But there is a way around it. If you have that named as a function, Maple uses the symbol d. So you can type d of x to mean the derivative of x, d of y to mean the derivative of y, and d of z to mean the derivative of z. So I can run this command, and there's that arrowhead. Let me color code this green so I can differentiate it. Let me name it something now. Let me call this the velocity vector. And then I'll go back up here and I will display the velocity vector. Oh no! It turns out I've forgotten to put the velocity vector at the right point. So I need to move it up to here. Remember, that point is just, well, this point, x of 5, y of 5, z of 5. So I'm going to copy that. I'll go back down to my arrow, and I want my arrow to start at this point, at x of 5, y of 5, z of 5, and then I want it to point in the direction of the velocity vector. So let me rerun that command. So now I've renamed the velocity vector as the new guy, so if I rerun this command, he should move. And look at that. I've got the curve, the position vector is indicated, and the velocity vector is moving in the flow of the curve and tangent to it. So I've got it good to go right here.